All right, welcome back. Today we're going to look at empirical formulas, which are the smallest whole number ratio of elements in the formula of a compound. So some background information here. First, a chemical formula. We need to know that that's a representation of the different types and quantities of the atoms inside of a substance. Now we can talk about formulas in a couple different ways. We have empirical formulas, which are the smallest whole number mole ratio of elements in the compound. This is an important definition because it's also going to basically tell us what we need to mathematically do. Most ionic compounds are also empirical formulas. That's just the nature of ionic compounds. And then we can also have a molecular formula, which is the actual formula of a compound. So for an ionic compound, typically the molecular and empirical formulas are the same. For a covalent compound, they might be the same, they might not be. So then just as a reminder, the subscripts inside of a formula, they represent the number of atoms in one molecule. So that's at the simplest case. If we're just talking about one single molecule or one single ionic compound, that would be the ratio in a formula unit. That's what the subscripts represent. On a larger scale, though, those subscripts represent the mole ratios of those substances. So we're going to focus on this concept of mole ratios for our math. So this here is to try to show you that the molecular formula, the actual formula, might or might not be the same as the empirical. So these are two ionic compounds. These are the same. This is a covalent compound. Notice that the empirical formula is half as big as the molecular formula. Subscript 2, subscript 6, subscript 1, subscript 3. So this was doubled. The ionic is the same. Here's one exception for ionic. When you have mercury 2 involved, mercury 1, the empirical formula can be different than the molecular. Then we have the carbon tetrachloride. Notice that these are the same even though this is a covalent compound. And then, for example, glucose has an empirical formula of CH2O even though it's C6H12O6. So how do we go about doing this? We have two basic setups. We have starting from a percent composition, which is a pretty likely way to actually do this problem because if you're mathematically trying to figure this out in a experimental setting, you're going to often find your percent composition first. So your first step is to drop your percent sign and go to grams. Now we can do that because if you happen to have, let's say, 30% of an atom, we're pretending that we have a 100 gram sample. So 30% of 100 grams is 30 grams. So drop your percent, add G. Get to moles of each element. So divide all mole values by the representative molar mass in grams of that substance. Number 3, divide them all by the small. Divide all your mole value answers from number 2 by the small. So divide them all by the small. And then finally, if you happen to be in regular chem or honors chem, you might have to do this step number 4. If after step 3 you don't get whole numbers, you might need to take that decimal value that you got from step 3 and say, how could I write this as a fraction? So like let's say it's 3.5, so that'd be 3 and 1/2. That 2 on the bottom is going to be your denominator that you multiply. You multiply all of your answers to number 3 by that 2, and that'll give you whole numbers. So how does this look? Here's an example problem of what that might look like. I'm taking this from percentages, so I need to drop my percent and add G. So I have 52.1 grams of carbon. I have 13.1 grams of hydrogen, and then I have 34.8 grams of oxygen. So drop your percent, add G. Then I need to get to moles. Now to get to moles, it's a simple factor label problem. Set up a single step grid. And then I need to put the molar mass in grams off my periodic on the bottom of each of these grids. So 12.01 grams of carbon is the same as 1 mole of carbon. 1.01 grams of hydrogen is the same as 1 mole hydrogen. And 1600 grams of oxygen is the same as 1 mole. Again, these are coming off your periodic table. So some units cross off. And then in your calculator, you get some numbers that look like this. 4.34 moles oxygen, 13.0 moles of hydrogen, and lastly 2.18 moles of oxygen. Now in this case, we got to moles, so that was your first step, get to moles. Second step is going to be divide them all by the small. So the smallest one is the 2.18. What we're trying to do is turn these decimal values into whole number values. And you do that by setting them relative to the smallest value. Since these are ratios, it turns the smallest value into 1 mole of O. The hydrogen ends up being approximately 6 moles of hydrogen. So it might not come exactly at 6, but it might be like 5.99 or 6.03. And then you just round to the nearest whole number. And then you get 2 moles of carbon. I see I made a mistake up here. This should have said carbon. So that means that we're just going to use these as the subscripts on our atoms. CHO order, C2, H6O. This is the empirical formula given these data. So that was from a percent composition, and from a mass composition just removes the step of drop the percent and add G. So you still get to moles, divide them all by the small, and if needed, you fix your non-whole numbers by multiplying by a denominator of a fraction. So we just said that was the empirical formula. What if you need to know the molecular formula? Again, empirical might be the same as molecular, specifically if it's an ionic compound, that's most likely the case. But if it's a covalent compound, it's hard to tell. So your first step to actually get the true formula of the compound is to get the empirical formula. We just went through that process. Get to moles, divide them all by the small, and then that should be your mole ratio. So once you have your empirical formula, figure out the molar mass in grams of that empirical formula, and then you're going to take that empirical formula molar mass and you're going to divide that into the true mass. Now this true mass can come from a machine. There's a machine that can detect this. In some labs, like we don't have those in chemistry, but in chemistry we just tell you the true value, but there are machines that can figure this true mass out. And you're going to divide the empirical into that true mass. Empirical should be smaller or the same size. And that's going to give you a multiplier. You're going to multiply all of your subscripts by that multiplier. So what does that process look like? This is pretty simple. So again, we're starting from an empirical formula. We're assuming that we have an empirical formula already. So in this case, our empirical formula is CH2. So step 1 is done. We need to find out how heavy this is. It's 12.01 for carbon. That's coming off my periodic. And then 1.01 times 2, also off the periodic, and then the subscript 2. If you sum this together, it equals 14.03. And again, that's grams per mole. So I just found out how heavy this empirical formula was. Now I want to find out how many times does this formula go into the true mass, because that's how many times I need to increase my subscripts. So 42.09 divided by the 14.03, that ends up equaling the number 3. So that's telling me that this true formula is 3 times bigger than this empirical formula, so I need to make my empirical formula 3 times bigger. So this 3 gets hit on to both subscripts, so C3H6. Now, if you're keeping track of what that means, this formula should weigh 4209, and 3 times 12, so that's about 36, plus 6 more is 42, so we're right in the correct ballpark. So this would be the true formula of the compound as compared to the empirical formula of the compound. After watching this video, you should understand how to calculate an empirical formula, both from percent composition data and also from mass composition data. After that, if you're asked to figure out the true formula of a compound, you should know how to do that by taking the empirical formula mass, dividing that into the true formula mass, and then multiplying the subscripts by that multiplier. Hope this helps.